Hello everybody. Today we will solve one question from this paper. Okay, let's see. Okay, question number 4. A particle P moves along the x-axis at time t second, t greater than equals to 0. The displacement of P from the origin is x meters. In this question, they indicate displacement as x meters and the velocity v meter per second of P is given by v equals to 2t square minus 16t plus 30. We will find the times at which P is instantaneously at rest. This is very important information. Number B, find the acceleration of P at each of these times. When t equals to 0, P is at the point where x equals to minus 4. Here displacement when time 0, displacement is x equals to minus 4. See, find the distance of P from the origin when P first comes to instantaneous rest. Okay. Before starting this maths, we have to show you some formula. Uh, if velocity give, so if you want to find out from velocity acceleration, we have to differentiate velocity with respect to time, then we will get acceleration. But from velocity, if we want to get the displacement, we have to integrate velocity with respect to time. Then we will get displacement. In some question, displacement indicated as a s also. And after integration, which term we will get, and we have to give here the integral constant. So this is the formula. Velocity when converting to acceleration, we have to differentiate velocity with respect to time. But from velocity, if we want to find out the displacement, we have to integrate velocity with respect to time. Some question displacement indicate as a x, and some question it is indicate as a s. In our question here, displacement is indicated as a x. Okay, now see how can we solve it. Velocity v equals to 2t square minus 16t plus 30. One information is very important over there. When particle p is instantaneously at rest, that time v goes to 0. It's a very important information. When p is instantaneously at rest, then v goes to 0. So we have to write v0 equals to 2t square minus 16t plus 30. If we divide both sides by 2, we will get t square minus 8t plus 15. Now, if we do factorization, t square minus 5t minus 3t plus 15 equals to 0. Take t common, t minus 5 minus 3 common, t minus 5 equals to 0. So that we'll get t minus 5, t minus 3 equals to 0. Therefore, t equals to 5 and t equals to 3. So the first answer, the times are 3 seconds and 5 seconds when velocity v is the particle is instantaneously at rest. Now, if we want to find out the acceleration of each of this time, we have to differentiate this velocity with respect to time. If we differentiate velocity with respect to time, here it will be 2 multiply 2t minus 16. So acceleration equals to 4t minus 16. So when t equals to 3 seconds, acceleration equals to 4 into 3 minus 16. It will be minus 4 meter per second square. When t equals to 5 seconds, acceleration equals to 4 multiply 5 minus 16. It will be 4 meter per second square. So within this time we get the two acceleration. Okay, a goes to minus 4 meter per second square, and another time we get when t equals to 5 seconds, then acceleration is 4 meter per second square. The part given when t equals to 0, x equals to, here x means displacement equals to minus 4. We have to find the distance of P from the origin when P first comes to instantaneous rest. We know that uh, P instantaneous rest when T equals to 3 seconds. Okay. So from velocity, if we want to find out the displacement, we have to integrate V with respect to T. So if we integrate V, so we will get here 2 t cubed by 3 minus 16 t square by 2 plus 30 t plus c. So if we put here x value, t value 0 and x value minus 4, so we'll get here minus 4 equals to all this part is 0. If we put here t0, this part is 0, that one is also 0, it's also 0. So see, we put here t value 0. Therefore, c equals to minus 4 here. So if we put here put c equals to minus 4 in equation 1, we'll get x equals to 2 by 3 t cube minus 8 t square plus 30 t minus 4. This is our displacement. Now, we have to find out the distance of P when P comes to instantaneous rest. Okay, now see, how can we do this? When t equals to 3 seconds, x equals to 2 by 3 cube minus 8, 3 square plus 30 into 3 minus 4. So after calculation, we will get here 32 meter. Okay. So I think everybody understand this maths. This is very important maths. One thing we have to remember, when velocity convert into acceleration, we have to differentiate velocity with respect to time. But when velocity convert into displacement, we have to integrate velocity with respect to time. That means when we want to get acceleration from velocity, we have to differentiate. But when we get displacement, we have to integrate. Thank you everybody for watching.